Assalamualaikum everyone. Okay, for today I want to discuss about some questions that involving long division and also the completing square. Okay, so we have done from the previous notes, we have done for the completing square and long division. So for the completing square, we have important formula, that is the formula involving tangent inverse and sine inverse. Okay, now let's look at the first example. Okay, solve the following integration using the suitable technique. Alright, so now we want to integrate x minus 1 over x plus 1 dx. Okay, so the first thing you have to do when you have the questions of integration is identify the types of your function. When you want to identify your types of the function, then you need to identify based on this tree diagram. Okay, so firstly, identify whether it is a rational functions or trigonometric functions, rational functions or trigonometric functions, or is it a trigonometric substitution or integration by parts. Okay, so obviously what we have here is a rational function. Okay, now for the rational function, you have to identify whether it is an improper or proper rational function. So look at here, we have the power of x in your numerator is equals to the power of x in your denominator. That means it is an improper rational functions. Okay, so what happens if you have an improper rational functions? Yes, you have to change into a proper rational function by using long division. Alright, so firstly you have to perform your long division, right? Okay, now let's perform your long division. Okay, we have x minus 1 divided by x plus 1. Okay, so firstly when you want to cancel off your x, it will be 1 here, and you have here is x plus 1 minus. Okay, so x minus x is 0, negative 1 minus 1 is negative 2. So your long division here, it will be, okay, the result will be 1 minus 2 over x plus 1, right? So meaning here we have simplify this rational function, and it will be the integration of 1 minus 2 over x plus 1 dx. Okay, so next is you need to integrate the simplified function. Okay, so we have here the integration of 1 is x, right? So integrate 1, you will get x minus, how to integrate 2x plus 1, 2 over x plus 1. Yes, to integrate 2 over x plus 1, you need to use long division. Okay, so for this one, sorry, you need to use u substitution. Okay, so let u is x plus 1, and then du dx is, differentiate x, you will get 1, and then write your dx as the subject. Okay, dx here, you will get dx equals to du. Okay, so when you integrate, you will get the integration of 2 over u du equals to 2 ln u, right? So now you will get the integration of 2 over x plus 1 will be minus 2 ln, your u is x plus 1 plus c. Okay, so I just move it this. Okay, alright. So this is your final answer. Okay, so this is the reason why we need to use long division, because we want to simplify. We want to simplify this one. Okay, simplify the rational function into the form of simplified function. So when you have the simplified function, now you can integrate using basic integrals formula. Right, class? Okay, now let's proceed with the next Example B. Okay class, now we have the integration of 5 over 2x squared plus 4x plus 3 dx. Okay, so again, when you want to integrate a function, firstly identify the types of your function. So we have here a rational function, right? So we have a rational function. Okay, for a rational function, you have to identify whether it is an improper or proper rational function. So we have here, it is a proper rational function because the power in your numerator is x power 0. So it is a proper rational function. Okay, for a proper rational functions, we have to identify whether your denominator, so we want to identify this denominator, either it can be factorized or cannot be factorized. Okay, you can use your calculator. So if you use calculator, okay, now we have to use the mod EQN, and then unknowns is 2. So the degree is 2, right? Power of 2. So your A is 2, your B is 4, and your C is 3. Okay, so the given answer here is x equals to -1 and x equals to -1. Okay, so please check. Okay, if you have x, -1 means x plus 1, x plus 1. When you expand, it will be x squared plus 2x plus 1. So it's not similar with the 2x squared plus 4x plus 3 here. Okay, so this is wrong. Make sure, please try or please expand the given answer from your calculator. Okay, alright. So meaning here you cannot factorize your denominator. So what happens if you cannot factorize your denominator? We have to use completing square. Alright. Okay, now, so the things that you need to use the completing square is just the denominator. Alright. So for the completing square, okay, we have here 2x squared plus 4x plus 3. Okay, since you have 2 in front there, so we have 2 here, so we need to factorize. So when you factorize, you will get 2x squared plus 2, 4 over 2, 2x plus 3 over 2. Okay, so by using the formula, we have here, this is your B and this is your C. Okay, so the given formula is, so 2x minus B over 2 square. So x minus 2 over 2 square, minus or plus? It is plus. Okay, and then minus 2 over 2 square, and then plus C, 3 over 2. And you will get the answer is 2, and then we have x plus 1 square minus 1 plus 3 over 2, and you will get the answer is 2 x plus 1 square minus or plus, so 3 over 2 minus 2 plus 1 over 2. So this is your completing square. Okay, so remember, the target, we want to use the completing square because we want to use the formula. Okay, this formula. Okay, we want to use this formula. Okay, so let's look at your denominator here. The denominator must be in the form of a square plus x square, or set of a square minus x square. So we only have two form of denominator here. The first one using tangent inverse, the second one using sine inverse. Okay, alright. So now since you don't have any square root there, Okay, in the questions, in the previous questions, you don't have any square root, meaning here we want to write in the form of a square plus x square. Okay, this is the formula that we want to use. Integration of 1 over a square plus x square dx equals to 1 over a tangent inverse of x over a plus c. So we want to write your denominator in the form of a square plus x square. So let's see here. So we have here, this is x squared and this is a square. So either x square plus a square or x square plus a square, it is the same. Alright, okay, so you have x square is x plus 1 square. Okay, and then you have your a square is 1 over 2. Alright, okay, continue. The problem now here you have x plus 1 square, which is not x. So we will write the formula in the form of u. Okay, so let's see here. We want to write in the form of u square. So the formula will be here is also u square, a square plus u square. Okay, you need to use u substitution later on. Okay, let's settle with this one. Integration of 5 over 2x squared plus 4x plus 3 is now equals to the integration of 5 over 2x plus 1 squared plus 1 over 2. Okay, so for this one you can write outside, so you have a coefficient here. Okay, you can write outside, so we have here 5 over 2 integration of 1 over x plus 1 squared plus 1 over 2. Okay, alright, so now okay, you have here is we have to write in the form of u. Okay, so don't forget your dx. When you write in the form of u, so now you will have it is 5 over 2 the integration of 1 over u square plus okay, I just put a square du. Okay, now let's see what will happen. So you have u is x plus 1, right? So your u is x plus 1. Let u is x plus 1, du dx is 1, and your du equals to dx, or dx equals to du. Alright, and then when you differentiate your a, okay, here we have a square equals to 1 over 2. So a will be equals to square root of 1 over 2. Okay, so now let's proceed with your solution. Okay, so we will have here, okay, we will have here is integration of 1 over u square plus a square. It will be, so this one you will get 5 over 2. So integration of 1 over u square plus a square, it will be 1 over a tangent inverse u over a plus c, right? Okay, so you can just write write in the form of u and a, then just substitute all your u and a here. So you have u is this and a is this. Okay, so your final answer will be 5 over 2. So 1 over, your a is sec 1 over 2 tangent inverse, your u is x plus 1 over sec 1 over 2 and then plus c. So this is your final answer. Okay.